Welcome to the first part of my definitive laser tutorial. This is going to be, as I mentioned in the showcase, an upgrade to the original one, where we go through quite a lot of things. I would suggest checking out the showcase to see if this tutorial is for you, and let's get into it. So I'm doing this tutorial in Unreal Engine 5.4, so it'd be best if you follow along in the same version, but I think most of the stuff here can go a few versions around without too many issues. So we're going to use the first person template, but if you want to use the third person, that's not a problem. None of this is associated with any of the playable characters, so to speak. So we don't need any starter content or any of these settings to change. I put this on scalable, but it doesn't change really, it's just visual. So let's get into it. I'm going to call this my project and let's press create. So welcome back. I hope your project is loaded by now. And the first thing we're going to do is we're going to make our own custom trace channel, just so we can keep everything as separate as possible. So if you want to do it on your own project, there's no issues there. So we're going to go into edit, project settings, wait for it to load, and we're going to go down into the engine and look for collision right here. And all we're going to add is a new trace channel, so this one right here, and it will be called laser, and by default we'll say block. Close this, we don't need it anymore. And now let's go ahead and make our assets or our actors and all that. So let's start by creating a new folder to store all our work in here, which we'll call lasers. Inside of here, we first want to get a new folder for our assets, another one for our materials, another one for all our blueprints, and for now, this will be okay. So first, what we'll do is we'll import our laser because we're using a specific static mesh, which I will make available in the description down below. So go ahead and import that in by dragging it in and leaving it by default. We just want to import all. And just to give you an idea, this is what it should look like. The main purpose of this is so that we have a pivot point at the bottom. It makes it much easier to scale than having to find the middle point and then scale half of that distance. So this just allows us to scale in one direction without any issues. Now that we have our laser in, I think we'll start off by making the actual material for it so that we can actually get that out of the way and not have to touch any kind of visual stuff after this. So let's pull that up, and the material has been improved since the last time, because the last one that I made did have a pulsing effect but wasn't perfect. So here I made it a bit better. So right click, material, M_laser. Okay, so we can go ahead and open that up. And what we can do to see the preview is if we go into our assets and select our laser cylinder here and click on the final button here, we actually get to preview our material on the actual mesh itself. So as far as the basic setup goes, we don't need to change anything here. And we won't be using this on any kind of instant static mesh or anything, so we don't need to change the used width. So this is fine. So I think we can start with a color. So we're going to press 4 and left click, which will create us a constant 4 vector, which we'll use as a parameter. So right click, convert to parameter, and call this color. Now by default, we don't want it to be black, so let's just make it red for now. And we're not going to plug this in yet. We're going to create a reroute node here so that we can reuse it everywhere else. So first here, we're going to call named reroute, enter, and we'll call this base color. And we are going to plug this in right here, so search for base color for the base color. But we're also going to add the obviously emissive color, and that's where we're going to make most of our changes. So we're going to get our base color again. So just copy this here and paste, multiply it, and we're going to make an intensity here. And normally this, you could say, could be enough. You could leave your laser with this and it would look okay. Obviously you put this more like 15, but we're going to do it a bit more than that to make it a bit nicer. So for this multiply, what we're going to use is a lerp. So linear interpolate, and I'll just line these up. There we go. And we're going to turn these into parameters so that we can modify them later. So this is going to be a scalar parameter value. and we're going to call this intensity normal. And we will then copy paste it, and we'll rename the second one to intensity pulse. So this is when it's actually changing. So we'll put this at 30 by default, so on normal at 30, and we'll put it at 80 if we're having a pulse. So plug this into the B, and now we need to make a mask, because right now it doesn't know how to do this, so it's kind of getting the middle ground. We need to make it understand what we're trying to do here. So we're going to make another named reroute node, and this is going to be called alpha mask. Sorry, I don't want to cover that. So actually detach it, because we want the alpha mask to be placed like this. And so here we're going to make our mask, and the mask is going to use a few different things. So let's go and set this all up, and you'll probably have to tweak the values yourself if you want to change it a bit, because they can be a bit annoying as far as setting up goes, but let's get into it. So hold down S and left click to get a scalar parameter, and this will be called spacing. And I put it at 100 by default, and we're going to multiply this. So what we're going to do here is we're going to compare it to the actual object scale on the Z, so the height. So that way the pulse will always be the same no matter which laser we're talking about and how scaled it is. So we're going to do object scale here, and we're just going to use the Z. So we're going to get this, and we're going to divide this, which is the max value, so the length, by 1 being so that we get a percentage. And this will be plugged into here, so it will change how the scaling works based on the actual size. Now with this multiply, we are going to get another divide here, and it's going to be on the B, and what we want to divide it by is the local position. So this one right here, there we go. And what we want to do is we want to mask, so not M, sorry, we want to look for a component mask, and we want to look for blue here, so just the blue color. And so here, so what this does is it gives us a grayscale on the Z. So that's what this is for. If we change this to the green, it'll be on the side, I believe, if I'm not wrong. Yeah, there we go, which is pretty useless to be fair. And red, I think, will be the same, yeah, RGB. So we want blue, and blue will give us a scale going upwards. So we can stop previewing this now. And now what we want is we want a panner node, because we want the actual pulses to move. So this will kind of give us the coordinates to move along, as it's a grayscale. And now what we want is we want to control the speed. So to make the speed, we need to get an append node, and we're looking for the append vector, so the first one, sorry. And with it, we want a value of 0 here, so just click 1 and left click to create a value. It's going to leave it at 0. Doesn't need to be a parameter or anything. And then for B, and this because we don't want it to move on X, we want it to move only on Y. So here we're going to need a scalar parameter, so S and click, and we'll call it scalar, we'll call it speed, because that's what it is, and put it to 1 by default. We will though multiply it by -1, because it needs to be inverted. Well, the direction needs to be inverted. So we'll multiply this by -1. Now with this, we don't just plug it straight into the alpha mask, we need to actually get a function or a custom, I believe it's called a material function that already exists, and it should be called generate band. And so what this will do is it will create a band that we will be able to move along by using this panner node as the input coordinates. Now, what we can do here, and what we're going to do, is we are going to also modify the width here by default 0.25. We're going to make it a scalar, so a parameter, so we can actually modify it. So pulse width, and once again, sorry, I didn't mention this, but S and left click to create this. So I put 0.7. Obviously, all this is up to you if you want to change it. And here we go. So this, before plugging in, one last thing, we want to make sure we floor this, because I believe right now we have kind of a, how to put it, it is scaling from one point to the other, so it's not very visible. But if we right click and look at the floored one, it will be kind of more obvious. We actually have a nice distinction between black and white here. So with this, we can then plug it into the alpha mask, right click, stop previewing. And now we have kind of a brighter color for that white area that we're talking about. So in addition to this, we want to make one extra change, and that is to add this mask to a world offset. So it feels like the line is getting bigger as it moves. So to do that, we want to get another scalar parameter, and this will be called pulse height. This pulse height will be 0.5 by default, and we're going to multiply it by 0.1, sorry, because we need to make sure that this is very small, because otherwise it really kind of destroys the whole thing if we don't leave it at a small value. So we want to lerp it between b being the value that we just inputted here and 0. So it really needs to be a very small value. And for the mask, or the alpha, we will use our alpha mask that we've just created above. So that way the offsets that we have are aligned with the actual color change as well. So we'll just multiply this right here by our vertex normal, world space, so WS. And we just want to plug this into the world position offset. And so it might not be particularly visible here, but if you want, we can make it a bit bigger and just leave this as 1 instead. And now you can see it's a bit more visible that it's actually deforming. But if we make it, because how right now it may look okay, but we're going to be making it a bit smaller because the mesh is a bit too big for a laser. So we'll be making it smaller, and that way, if this is left any higher, it will look like if we did this, for instance. And it would look a bit, or no, this to be fair is still good. It would look more like the mesh is starting to break itself. So for now, we'll leave it at 0.1, and this should work fine for once we scale this down. So this does it for the material. And now we can move on. Well, first we can actually see what it looks like when we scale it and actually attach it to our material. So let's go and drag our mesh in here, for instance, and we will rotate it and scale it up on the Z. And we'll apply our material to it. So here we go. Okay, so sorry, I made a mistake. And although this is good, we're going to make a material instance that we'll use, which is actually a bit different from these values. So laser right here, attach this here. It should just look the same for now. And we're going to change this, or change the values for now. And the values we will be changing is spacing will be 800. Speed we'll leave at 1. The pulse width we'll leave as well. We want to change pulse height to 5. And we're going to change the intensity from 100 on the pulse and leave this at 30. So now if we compile and save, this doesn't look great, but if we change this to what it's going to be later, which is around, I believe, 0.1 and 0.1, it looks good. It doesn't deform it too much, and we can clearly see the actual laser pulsing through. And obviously, if you want to change these values, that's up to you. You're free to change them. It doesn't really impact the tutorial at all. Okay, so now we can get rid of our laser and actually make a laser blueprint. So that's what we're going to be working on mainly today. So for the following part, what we're going to do is mainly set up the basics for creating a spawn and creating a system kind of to set up expanding the spawn and a box that we hit later. So the first thing for that is an interface. So we're going to start, actually, sorry, no. First we'll make a folder. And this folder is going to be called building blocks. And the reason we call it that is because it is going to be the laser actor. It's going to be the different components that we're going to attach to actors to make them function as we want. So this way it's more scalable, and if you want to turn any of your actors into the kind of system that we're making here, then that is possible. So inside of here, right click, and the first thing we're going to make is a blueprint interface. So right here, and we will call this BPI lasers. Alongside this, we are going to have an actor, and this is going to be our A laser. And we're going to have another one, which for now is going to be our main actor component, which is AC. It's going to be handler. And sorry, I forget one more. We do need one more for now, at least for this part. And that is going to be a scene component, and that is going to be SC emitter. So let me just briefly explain what they all do individually. So a laser is exactly what you probably think it is. It is the laser itself. It is going to handle making the laser longer, stopping it if it hits something, making its particle effects once we do that later. That'll all be handled in the laser. It will also inform whether it hits an object. If that object can be activated, that'll be done elsewhere. And so that is the handler. The handler is going to be the kind of mandatory part that needs to be on an actor for the whole system to work. It'll handle things like conditions, as well as telling the other components like the emitter to actually start working. The BPI, or the blueprint interface, is going to be the part that actually connects all this together, because that way, if ever you don't want to use the handler or want to have a specific function for a specific actor, then you can use the BPI lasers to also use these functions as well. Although we'll set stuff up so that it works externally via the handler as well. So this is more necessary for the communication between these two right here, for instance. And the emitter is pretty much just a point in space that we can use as a component. So that's why it's a scene component, not an actor component. So that we can place it on, for instance, our cube and say, well, the laser will spawn here facing that direction. And we can use it to override some conditions here based on the handler. That's the point. So I think first we will start with the laser, because the laser can work on its own. It doesn't really need the rest. So we will start there. Actually, no. I think first what we'll do is we will do the BPI. That way it's out of the way and we don't need to deal with it anymore. So for now, we'll go at the end of this, we're going to need 6 different points, or 6 different functions, sorry. But for now, we're only going to do 2 of them. So the first is called actor start, or sorry, laser hit, we'll call it. No, you know what we'll call it? Laser start hitting. Second one is laser stop hitting. And so what these do, and the reason they're called like this and not activate and deactivate, is because later on we're going to set up to invert the system. So we want to make sure that this is in our mind, that we think of it as just the laser hits and laser stops hitting and nothing else. That's all it's going to do. So in the case where it starts hitting, we need to know 2 things. First, what is hitting, and second, where is it hitting? So the first thing is we're going to add a input, and that input is going to be a laser, because those are the things that are going to be hitting the lasers. And so this, we'll call this input is fine. Next, we want to know how it is hitting, what kind of input we're getting there. So for that, we're going to get a hit result. So we'll look for hit results, and this will be our hit info, we'll call it. So for stop hitting, on the other hand, we only need to know which laser stopped hitting, because it is no longer causing an impact, so it can no longer actually have a hit result. So we'll look for just a laser. Plug this in and call it input as well. And we can compile and close this for now. So the first thing we want to do with our A laser is pretty simple. We want to add our static mesh, because right now nothing is there. We want to actually have it be visible. So we're going to add a static mesh, and we are going to leave the default scene just because it's easier to handle without it. So by default, we have nothing. We want to select our static mesh here, and we'll look for static, laser. And I believe it is laser cylinder right here. So select that. And now we have our laser set up. So for now, it looks like this, but we're going to handle it later so it's thinner, because right now it would look pretty bad. One thing we do need to do first, is we do want to change this to be minus 90 degrees. So it's pointing kind of forwards in the actor. No, sorry, one last thing actually. We need to change the collisions, because right now we can actually walk on our laser, which is a bit weird. And so we don't want to do that. We want this to be custom, and we'll just put it to ignore all. And we can just also turn this collision off. One other thing we can do, and this is visual, it's not really that important, is the fact that this is a laser, meaning it emits light, so it shouldn't cast a shadow. So in our details, we're going to deactivate the cast shadow. Let's start with our begin play. So on begin play, we're going to want to create a material for the actor. So create dynamic material instance, and we're going to use the material instance we just made. So mi underscore laser. It's like this. And we can give it a name if we want, but it's not too important. We're going to promote this to a variable, which will be our material instance. And let's set our material of our static mesh here. So grab it and say set material. And so just attach this. And now to set the material, we'll just grab our material instance here and plug it in. So to make this work now, we need to actually tell our material what color to use, because right now it that's the main thing we're going to change, and that is the color. For now, we're not going to touch it too much, but I'm going to just set up the basics for it to work later. So with our material instance, we're going to place it here by copy and pasting, and we're going to say set vector parameter value, plug this in right here, and for the value, we're not actually going to plug this in or create a value. We're going to drag it out, press R to create a reroute node, and we'll just set the parameter name to color, and we're going to right click this and say collapse to function, and this will be called change laser color. And the reason we're making a function out of this is because we're going to need to change it later. So right here, the value we're going to put in here is going to be a parameter. So not a parameter, a variable. So select promote to variable, and we'll call this color override. As I said previously, the emitter is going to be handling most of the spawning. The laser isn't going to do much of that at all. So what we're going to do is we're going to select our color override, and in the details panel, we're going to make sure it's instance editable and exposed on spawn. And just to keep things organized, what we'll do is we will create a category for these because there's going to be a few exposed variables. So exposed, we'll call it. So right now, if we take our laser and attempt to put it in the world, right now it looks kind of with the default material, but if we play, it will be black right now. Yep, so right now we have a black laser, and as you can see, it's getting bigger because of the material that we made. Now, if we make this longer, just to get, oh, not that kind of longer. Oh, sorry, that's my bad, because we need to make some changes. It won't scale like that. So just to test if this is working, we'll make this red instead of black, and we will play. And there we go. So now we have a nice bright red laser with something scanning or pulsing through. Now, the end is invisible because it's always going to be against the wall, so it doesn't matter. So now let's make it extend. Let's make the laser actually hit stuff. So we're going to do that with a basic line trace. So I believe some people prefer to use a box trace. If that works better for you, that's fine. In my case, it has worked quite well with the line trace, so I'm going to stick with that. So we want to use the event tick here. And in the event tick, we're going to search for multi line trace by channel. Drag this out so we have a bit of space. And what we're going to do is we're going to say get actor location, which is going to be our starting point. And what we'll do is we will use the forward vector, so which will be this direction here. And we'll use that as the endpoint. So here we'll put a plus. Plug in the end, we will say get forward vector, and we're looking for the actor one here. And we will multiply this, and here's where we're going to get our second exposed variable here. We're going to right click this and convert it to a float. And from here, we're going to create a new variable. So we'll call this range. And just like with the color override, make sure it's instance editable and exposed on spawn. Drag it into the exposed, and we can just line this all up. And make sure, and I haven't done this yet, but we want to have a value here for the range, because by default it will be 0, and that is useless because the line trace will not exist. So make sure you set this to something like, I believe 3000 or 3000 will do. And just to check that this is working, we're going to do debug type for one frame, compile, save, and let's just play. And now, there we go, we have a line coming out. Now, obviously right here, it is hitting the wall because I think it is behind the wall, if I'm not incorrect. So normally, so the reason this is yes, indeed, it is hitting the wall because it's on the wall. So 0 is hitting that. But in most cases, the laser will either be spawned by something or attached to something that is already off of the wall, and that object itself will be ignored. So we don't need to actually bother with that. So let's just move it a bit forward to see if it's working correctly. And it is indeed, it is blocking there. And for now, it is not actually getting blocked by the player. And the reason for that is because we have set it to visibility. And if you remember, the first thing we did for the video is we actually created our own channel, which was laser. And by default, laser is blocked by everything. So right here, if we stand in front of it, it stops as well. So it's working as intended. Let's move on to the next step, which is changing the length. When we change the length, we only want to change the length if it's actually something that is blocking the laser, because in our case, the player blocked it entirely, but there are some actors that might overlap with it. So to determine that, we're going to do a little function that will handle this. So this might get a bit messy at first, but it's going to be pretty clear once it's done. So we're going to add a reroute here, and we're going to for each loop through this reroute, because we don't have much of a choice. We need to check whether something is blocking. So how we're going to do this is we're going to have two things. First, a sequence. And the first thing we do in the sequence is we're going to determine the length. And so to do that, we want to get from here a break so that we can check if it is blocking. So just put a branch here on the first part. If it is blocking, we're going to update the length. And to update the length, all we have to do is get our distance, put a reroute, select it, right click, and say collapse the function. And we'll just do it this way. We could do it all in one spot, but we're going to actually reuse it at the end as well. So right here, we're going to say update length. And so the reason we do it as a function is because if we hit nothing, then we still need to update the length to be the max. So right here on false, we're going to update this and say range is the input pin, because range is the max distance we can use. So let's close this, and we can actually go into our update length now. So in our update length, instead of doing a basic, we will scale immediately, we're going to do a check. And this check is very simple. It's just so that we avoid updating the distance every tick. That way, we just want to do a branch here and check if the distance is currently the same as it was previously. Because in that case, there's no point in updating it, and we'll just avoid redoing a scaling of an object for nothing. So we'll just put a branch, and for that branch, we're going to check if this is nearly equal. And the value we're going to put in here is a new variable. We're going to call previous length. So create a variable previous length. And for the error tolerance, I just put 2, just to give it a bit of extra space to work with. So let's move this here. And we want to make sure if this is not the same. Because if they're equal, we don't want to do it. But if they are not equal, then we want to keep going. So to keep going, the first thing we want to do is we will get our input pin. So input pin. And we're going to set it to our new previous length variable that we just made. So plug this in right here. And then we're going to say set, for our static mesh here, we're going to say set world scale 3D to this new length divided by 100, because it's in distance and we need it in scale. And I made the mesh so that it is 100 units long, so that means we divide by 100. So divide by 100 right here. And we want to split the scale. And we're going to put 0.1 here and 0.1 here. And the Z is where we want to plug in our actual length. And so with that, we're done. That does the length. So now if we play, the laser actually goes all the way to the end, and it is pulsing as it should be. And if I stand in front, it will update and now appear in front of us. And otherwise it will go back towards the end. There we go. So that does it for creating our basic laser. Now with this, we can do most of the rest, but we're going to set up some other things first before we do that. The first thing we're going to do is in our event graph, we need to do the rest, what was going to happen here, that is. And so to do that, just to keep things more organized, we're going to right click to drag this here. And we're going to add another one, and this one we will collapse into a function. So right click on it, collapse the function, handle hit actors, we're going to call this. So right here. And there we go. So what this is going to do is it's just a kind of more organized approach. We could have done this in the event graph, but it's not as tidy and it's not as easy to use the variables. So this input pin, we're going to do two things. First, we're going to check whether the target we hit is valid. And to do that, we will check if it has the component that we're using. So that component is our AC handler. So get our actor here. So hit actor, get component by class, singular. And if it has one of them, and it should only ever have one, we're never going to need two. If it does have an AC handler, that means we can work with this. We can actually use it. So what we're going to check right here is valid. If it is valid, that means we can keep going. If not, we stop here because we don't have a valid target. So now we're going to promote this to a variable so we can use it. So drag it out, promote to local variable, and we'll call this L handler for the local handler. So is valid, plug it in here, and there we go. So there's two things we need to do here, actually. No, sorry, one thing. And this thing is the miracle that I somehow didn't manage to do before. And this is here, we're going to stop the infinite loop. So we're going to add a reroute here. We're going to add another reroute here. And we're going to select both of these, right click and say collapse the function. And it will be called is not on path. And what this is pretty much going to do is it's going to allow us to check recursively which handler or which laser already hits this laser previously, so that we don't recall the function infinitely and that we don't activate objects in a loop. So let me just save that. So we're just going to turn this into a pure, and we are going to connect our local variable like this instead. So I believe we are missing some elements to do this, and we will add those as we go. So let me make my way through this. So the first element we actually need is we need something called previous lasers. So we're going to go and make that. So just duplicate any of the variables for now. Call this previous lasers. Pretty much what this variable does is it's just going to store which lasers are hitting the current handler. And they'll be passed through because they're actually going to be visible like these override and the range. Like this override and the range, sorry. So right click on float. So it turns into an array, and then we're going to select a underscore lasers. Laser. There we go. Change it to the object reference, and we're going to turn it to instance editable and expose on spawn as well. So put it in the exposed. That way we have them all in the same location. So if this is not empty, so is not empty, that means that we have something we need to check for. If it is empty, on the other hand, that means that we're talking about a spawn, and the spawn doesn't have anything interacting with it, so it doesn't matter. So in that case, we just ignore it. So right here, return true. That means that there is nothing on the path and that this is fine to keep going. Now, if this is not the case, meaning this does have some lasers in it then that we need to take into account, we're going to do a for each loop through them. So press F and left click for a for each loop, or type it in. So if we reach the end of this loop, that means we're good. That means there's no issues. Otherwise, something's wrong. So to check if there's something wrong, we're going to check if the laser here, if the handler that is controlling it, and I don't think we have that function yet, so we're going to, that variable, so we're going to create that as well. If we have that handler, and it is the same as the input handler we have here, so I'm actually going to change this to input handler. If the input handler is equal to the previous laser hitting it, then that means that we have an issue. So that means that we're going to have a loop if we're not careful. So that means we need to stop it. So what we're going to do is we're going to create a variable here. I'm just going to promote this so we have the variable. So promote to a normal variable, not a local one. And we'll call this owning handler. And so let's detach it. And this one, just like the exposed, is going to be instance editable and expose on spawn. So drag it in here as well. It's what we want to check is this... Sorry, actually one last thing we need to check. We're just going to promote this to a variable very quickly as well. So this is going to be local variable. I'm going to call it L current laser. And so right here, our current laser is our current laser's owning handler equal to the input handler. So is this double equal to our input handler? There you go. So this is what it should look like at the end. We're checking our current laser if its owning handler is the same as the handler we are checking isn't already in the loop or isn't already on the path. So if it is, that means we have to stop. That means there's a problem. So that means we ignore this laser or this hit target, sorry. So here we will return false. So make sure this is false here. And this one true and this one true, but this one has to be false here. Now we're going to do one last check here, because even if it isn't the case, we need to know if that owning handler or that laser doesn't have the same problem behind it. So to do that, we call our current laser, and from the current laser, we will call is not on path. But instead of doing like we did in our handle here, where it's our newly hit thing, our newly hit handler, we're going to tell it to use the handler that we're talking about in this laser itself. So it's going to check in the previous laser if the laser now is having an issue, or is its handler that it's hitting a problem back down the path. So we call here our input handler as well. And so if this returns false, then we're going to also return false here, because that means that something went wrong somewhere down the line, so we should stop and we don't handle it. So there we go. So just to check that this is correct, we want to make sure this is false, this is false. So if we reach the end of the previous lasers, that means we're good, we can keep going. Or if there were no previous lasers, we can keep going as well. Otherwise, we need to make sure that we've set it to false here. So we can close this and we can keep going. So now we're going to add another element. Now this element isn't useful yet, and it will mainly be useful for the reflectors, which we'll be getting into, I believe, in the next time or the time after that. So here we're going to create a new function, a new variable again. I keep mixing those two up. This variable is going to be called hitting handlers. So what it is we're going to get our AC handler here. And we're going to turn this into a map by, on the right here, turning it to a map. And instead of integers, we want to know the hit result. And the reason we want this is just so that later on, when we have a reflect, if we deactivate it or activate it based on conditions, we store the information of which handler got hit and how it should handle, or how that laser should rebound later. So right here, because it was allowed, then we want to add, so drag this in, add, and what we want to add is our input, or our handler here, and our input pin is the actual hit result itself. So get input pin right here. So now the next thing we want to do is we want to check if we need to activate the handler that we're hitting right now. And so to check that, we're going to make another variable, and this variable is going to be a set. From the handler, we're going to promote a new variable, so promote to variable here, and we will call this previously hit handlers. And so just delete this and make sure you reselect it here on the left and turn it into a set. And so with this, we're going to drag it back in, hold control, and we are looking for, does it contain handler? And if it does, that means that we hit it on the tick before. So that means there's no need to activate it, because we don't need to. It already knows that it's activated. So in the case where it is already activated, or already aware that it is activated, we will later call the update function. So right here we'll call actor update, but right now we don't have that. So what we're going to get is our handler here on false, so where it doesn't contain it, and we're going to say hit or start hitting as a message is fine. Put it onto false, and for the input, it is going to be self, because that is the laser that is hitting. And for the hit info, it's going to be the input pin. So there we go. So this is what it should look like. Now, the last thing to do here is we've just added our previously hit handler. All we need to do is let it know that this handler has been added to the list. So we'll say add, and we will add the handler. Now make sure for here, we put it on both. Because this is a set, it can never have 2 times the same anyway, so it will make sure it doesn't have any duplicates. Back in our event graph, so we can close this for now. We've already updated our length if it doesn't hit anything. The last thing we need to do is, on our completed, we need to make sure that we get rid of the previous handlers. Oh, sorry, no. I made a mistake. In the handle hit actors, I made a little mistake here. This is actually, we're going to need a second one. So we're going to promote this again to another variable, and this will be called current hit, I can't write, handlers. And so this one right here, delete it, and we need to replace our previously hit here with the current hit. So make sure this at the end is current, but this can stay previous. It's just that this tick, we have hit these new handlers, so add them here. So back in the event graph, now we actually need to handle getting rid of them, getting rid of the old ones. And so that's why we have a previous and a current. Now to tell this, we have a function called the difference, which will give us which are in the first but not in the second. So whichever ones are within previously hit but cannot be found in the current hit, right here is what we're going to loop through and actually stop. So on the completed, so once we've gone through everything we've hit, we will drag this out and say to array, plug it in. And from the array, we'll do a for each loop. And in the for each loop, it's pretty simple. We're going to say stop laser hitting because it is no longer actually hitting it. And once again, it is self right here. And what we need to do here is obviously as well, we want to make sure from our map here, our hitting handlers, that we say remove this. Because this is a loop through the handlers that were previously there. We want to make sure we remove it from our hitting results that we have here. So there we go, just a reroute to make it more readable. And just to make sure everything's working correctly, we want to make sure that now we reset the two different sets by going previously hit right here and setting it to the current hit and making sure we clear the current hit by copying it and saying clear. So attach this, compile and save. So with this now, we update the length. We tell the different items that get hit that can be hit that they need to be hit if they are, or that they will be updated later, even though we haven't put that yet. And here we get the difference to tell which old ones no longer need to be hit and need to be deactivated right here. Now, one thing I did forget to do, which is actually quite important, is in our class settings here, we want to make sure that we add the interface. So that is from a laser, we want to add BPI underscore lasers. And so that will make this appear here. And we will use this right now, even though currently it won't do anything. We're going to add the stop. Now for the start, we won't need it because the laser can't be hit, so it can only be stopped. So what we're going to do here is a sequence. At the end of the sequence, we are going to say destroy actor. We're going to destroy the laser itself. And on the start, what we're going to do is with our previously hit handlers, we're going to turn it to an array. And with that array, we'll make sure that if this laser ever gets deactivated, that it will stop any of the handlers that were hit and tell them to deactivate their lasers as well. So we'll call stop hitting. And the input will be self. And the reason we don't need it, obviously, from this input is because, well, it's a laser telling a laser to stop. So the laser that's stopping is itself anyway. So it doesn't matter. It doesn't need that information. So with that, we've finished the main setup for our initial laser. And I think I'm going to leave this part here because it's already almost an hour, and I think that is long enough. And in the next part, we'll be adding our emitter and the basis for all the rest of the stuff. So I will see you in the next part. Thank you everybody who's supported me on Patreon for the last month. At the end, once the last video of this comes out, the project files will be available on Patreon, commented as usual if that's something that you want. Thank you for watching, and I'll see you in the next part. Goodbye.